True. Always true. True. Always true.
Good afternoon. I hope everyone's doing well today. So, we're getting back into some more C++. I'm hoping that I've retained the information that I had over the that I've acquired after having a weekend of not doing any of this stuff. We are 8 hours through our 31-hour video, so we're a little over a quarter of the way, I think. I mean, 7 hours and 53 minutes into our 31 hour and 7 minute. I don't know who's going to be keeping track of it that closely, but it has been a lot of fun. So today we're going to be going into loops. We're going to do kind of like I said on with chapter 5 on Friday, where it's with flow control, where the section says it should be like a little under an hour long. Because I have to go through and type it and do all this stuff myself, we might get into arrays as well today, but I'm not going to count on it. If we complete chapter 7 and it's relatively quick and I'm still feeling like, oh yeah, we can keep going, then we'll probably continue with loops or with arrays. But I'm I don't want to count. I don't want to promise that we're going to be doing 2 chapters in a single day. That said, uh, I am. I've got the video up. I've got my my gamer sups. Veggie Squad is here. I'm just doing manga work, so I won't say much. That's understandable. So for anybody who happens to be wanting to follow along with this, whether that's live or as a VOD watcher, or whatever it may be, this is, I mean, obviously, in the video that I have linked, it's Chapter 6. It has the timestamp right next to it, 7 hours, 53 minutes, and 49 seconds. And let's get into it. I'm excited to get back into it and see how much of this information I've forgotten or retained or whatever. What I might need a refresher on. All right, let's go. All right, so one of those popped up. Does the other one want to play nice? No, because it's the wrong project. Understandable. There we go. All right, let's go.
To be learning about loops. And this is a construct that is provided by the C++ programming language to allow you to do repetitive tasks relatively easily. Suppose we have a task to print a message 10 times. We can go down and do it like this, and it is going to work. But what if they try and tell you, do this 100 times? Then you're going to start scratching your head, you're going to type this 100 times, and you're going to run your program, and it is going to work.
See,
then
that
your
sounds like
manager
it would
comes up
be-
and they say, I want you to do this 10,000 times, or even 100,000 times. And then you're going to start pulling your
very
hair,
quickly becomes
running around,
inefficient.
breaking things, because that's impossible to do. Not to worry here.
I mean,
C++
impossible,
provides
no.
a way to do this relatively easily, and we're going to be learning
Definitely not
about
the
ways
most
we can
efficient.
do this in our program
Right.
in this chapter. The constructs we're going to be using are these you see here. There is a for loop,
range-based for
loop, a while loop, and a do while loop.
loop.
And we can make use of these tools to not go crazy printing a message 1 million times, because that's really bad. Okay, so
I wonder
that's
if I
what
could make
we
it
are
something
up
print
against in
a
this
million
chapter. We're going
times,
to be learning about
just for
these
me,
loop
for
constructs,
shits and giggles.
and you're going to find that they are really cool for your application. I am excited to be teaching you this, so let's get started in the next lecture and learn about the for loop.
Yeah, let's do
Go
it.
ahead and finish up here and meet me there. In this lecture, we're going to learn about for loops. For loops are one of the constructs we have in C++ to do repetitive tasks. They allow us to do something like this much more easily. For example, we don't have to type stdc out I love C++ 10 times or 100 times. We can do this in less than 5
I had a
lines.
dream I was trying to
and you're going
save you
see
from
how
a pack
cool
of
this
zombie
is.
animals
The
in the
syntax for
post-apocalypse,
for
and I
loops
do not
look
know what
like
the
this.
fuck was
And
happening.
it may look
Wow.
intimidating for first users, but we're going to break this down. We have a few parts in here. The first part is the iterator, which is a variable that we're going to be using to navigate through the loop. And that variable is this unsigned int I here. We are going to initialize this to 0, and the value we initialize this with is going to be our starting value. And that's another key point of any loop. Any loop is going to have a starting point. We are also going to have a test, which is going to control when our loop ends. For example, this loop is going to start with I equal to 0. It is going to keep doing stuff until I is no longer less than 10. As long as I...
Oh, so that's what we learned this part before. This is the increment, right? So we can do... So what it does here is we start I at 0, and then I is less than... As long as I is less than 10, do this. And then for each time it does it, it increments I by 1. So it starts at 0, increments it by 1, prints I love C++. Then it's at 1, you know, and it repeats until it comes to 10. Okay, so that's pretty. Okay, wow, I'm understanding it. Holy shit!
I is less than 10. It's going to keep doing whatever it is we want to do. And the first part of the loop is this plus plus I thing here. And this is an incrementation part. That's how I'm going to call it for simplicity, but it is a part that keeps changing our iterator to make our loop move forward. After these 4 points, we are going to have a pair of curly braces, And inside these curly braces, we're going to have the body of our loop. And this is the code we
This is
want
the
to
thing that we want.
execute multiple times. And inside this loop
Yeah,
body, we can really do all kinds of crazy things. You're going to see how cool this is. Again, we have a few parts with our loop. We have our iterator, which is this variable I here. We're going to be initializing this with a value that denotes where we want our loop to start. We then have a test, which is going to control when the loop is going to end. We're going to have our incrementation part, which is going to allow our loop to move forward, and it's going to be doing that through increment iterator, which is this variable I here. We're going to be initializing this with a value that denotes where we want our loop to start. We then have a test, which is going to control when the loop is going to end. We're going to have our incrementation part, which is going to allow our loop to move forward, and it's going to be doing that through incrementation or decrementation. But to make explanation easier here, we're going to call this part the incrementation part of the loop. After that, we're going to have the body of the loop, and it's going to be within these curly braces, and it's going to be whatever it is we want to execute inside this loop. Okay, these are the parts of a loop, and you need to keep this in mind.
Your starting
okay, now
point.
that you know the main part.
So we have our iterator. We designate I as the iterator. Or no, isn't it? Hold on. We have iterator, starting point, test, our increment, and then the loop body.
The parts of a loop, and you need to keep this in mind.
So this is our iterator, and our starting. So iterator, starting point, test, incrementation, body. Right? I think that's what it was.
Okay, now that you know the main parts of a loop, how does it really work? Let's go through this and see how it's going to print I love C++ 10 times. So when this code gets executed, we're going to start with I equal to 0, because that's what we are initializing this value with. After the incrementation part, we're going to run the test, and the test is going to say is I is 0 less than 10, and that's going to be true. So if the test turns out to be true, we're going to jump into the loop body. And if it's false, we're going to jump to the end of the loop and execute whatever is after our loop. This is how it works. So if we jump in for the first time when I is 0, we're going to print I love C++ for the first time. Then after the body is executed, we're going to execute the incrementation part. This is going to make I equal to 1. Then we're going to come back to the test. We're going to say is 1 less than 10. That's going to be true. We're going to come in the body and print I love C++ for the second time. After that, the incrementation part is going to run. We're going to have a 2 inside I here. 2 is less than 10. This is going to be true. So we're going to fall in the body again and print I love C++ for the third time. We're going to keep doing this until we hit 9. For example, if we increment and get a 9, we're going to fall in the test and say is 9 less than 10. That's going to be true. So we're going to fall in here and print I love C++ again. And after that, we're going to run the incrementation part again. This time, I is going to become 10. We're going to do the test. 10 is not less than 10, so the test is going to fail. And we're going to fall on the outside of the loop here. And by that time, we will have printed I love C++ 10 times. And this is really how a loop works. For the first time, we're going to run this initializer part here to initialize our iterator, which is this value I. And then after that, we're going to run the test. If the test is good, if it's successful, we're going to fall in the body. We're going to execute whatever code is in the body. And after that, we're going to keep doing the cycle increment test body, increment test body, increment test body until we hit a point where the test fails. And if the test fails, we're going to fall outside this for loop here. We're going to execute whatever is after this closing curly brace. And this is how a loop works.
I wonder, so maybe he'll get into it, but I wonder if we can, like, what kinds of things we can use to test a loop. Like this is a fairly easy example. Like we have our is I less than 10, because we just want to run it 10 times, like, period. But I wonder if, like, you can create other conditions that are that fit into that. I wonder if there are other conditions you can put in a for loop uh, as the test in order to stop it from, in order to decide whether it loops again or not.
I want you to go through this one more time by printing I love C++ and making sure that this is printed 10 times. And one thing you should have noticed now is that we use this test to control how many times the loop is going to start. For example, if we wanted it to run 20 times, we would start from 0 and end at 20. And you don't always have to start from 0. You can really start from anywhere. For example, you can initialize I with a value like 30 and end when I is equal to 55. Let's say that as an example. You can really do anything. The main important thing is to understand how a loop works. One thing I want you to notice is that we are saying unsigned int here to declare our iterator. Iterators are a common thing in C++ code, and they're not just used for loops like we are doing it here. There is a type we use to do iterators, and it makes our code much more readable, and that's called size t. This thing is a representation of some unsigned int type in your C++ compiler. This is going to be different from compiler to compiler, but for example, on my system, this is 8 bytes. So it has quite a good range of values you can put in there. If we use size t type to declare our I iterator here, we're going to say something like this. For size t I, we're going to put our curly braces, we're going to put a semicolon, we're going to put our test, and we're going to put our incrementation part. And I think I really emphasized this, but the parts of our loop inside these parentheses are separated by semicolons like this. So we have the iterator declaration, we have a semicolon, we have the test, we have a semicolon, and we put our incrementation part. And then we go on and put our curlies, and inside we can do whatever it is we want to do inside the loop. So size t is something you're going to see a lot. Make sure you know what it means. Remember that it is a representation of an unsigned int type. So it can only represent positive numbers, and it is used to represent things like sizes in C++. Think the number of students in a classroom, for example, that can never be negative. Think about the number of seats in a car. That's something that is always going to be positive, and it won't make sense for that to be negative. So for those kinds of things, we can use size t to represent the size of those things. And you're going to see how this works in a minute. Okay, now that you have a pretty good idea about how a loop works and the main parts that make it up, I want you to know that you can also do all kinds of crazy operations inside the body of your loop. For example, here we are printing out the current value of our iterator, and we're going to print the double of that. We can do this. We can also leave out the curly braces, and this is only valid if we have one statement we want to run in the loop. So this is going to print this message here 5 times because this loop is going from 0 all the way to 4. It is going to stop when I stops being less than 5, and this is going to be 5 times. If you go through this, you're going to see that this is going to print 5 times. You should also know that this iterator that we are declaring like this is going to be scoped inside the body of the loop. So you can only use it inside these curly braces. And if you try to use it outside, for example here, after the closing curly braces of the body of the loop, you're going to get a compiler error. Again, you can only use this variable I, which is our iterator, inside the curlies that mark the start and the end of our loop body. If you want the iterator to be usable out,
hold on. I don't think I understood that.
Which is our iterator inside the curlies that mark the start and the end of our loop body. If you want the iterator to be usable outside the scope of the for loop, you can do something like this. You can declare your iterator outside the loop, and you can initialize that with whatever you want, and then you can set up your loop like...
Oh, I didn't even catch that was going on before. I kind of assumed, I think, that this size t, that the iterator value that we were using was being initialized outside of it, for some reason. But so we are initializing our iterator inside of the loop. for the most part. And if we initialize it there, it's only usable within the for loop.
A loop body. If you want the iterator to be usable outside the scope of the for loop,
that's interesting.
You can do something like this. You can declare your iterator outside the loop, and you can initialize that with whatever you want. And then you can set up your loop like this. You can say for J and put in your test and your incrementation part, and inside do whatever it is you want to do in the body of the loop. If we do it like this, then J is going to be usable outside of the loop, and we're going to see its value.
I just need to focus on how the fuck to draw a human.
So this is also something
I believe in
do.
you.
You can even go all crazy and leave out the declaration part if you happen to have the iterator declared outside. So if you do something like this,
is there a reason that you would do it?
Okay, the last thing I want you.
Is there a reason that you would want? He gave a reason, but I'm trying to think, like, are there? I can't think of any situations that like pop out or that are obvious to me as to why you would want the iterator used outside of the for loop. I feel like that if you're using the for loop, you'd kind of want your iterator, you'd want it kind of controlled, wouldn't you? I mean, I guess maybe there's some use for it where, like, maybe you use the same iterator in different places, and it might be worth doing that way, and changing the value of the iterator then. But in that case, I guess it depends on whether it needs to be how. I think what it depends on then is how interconnected that particular for loop is with the other systems in the code. Interesting.
To see before we head over to Visual Studio Code and actually try this out is that it is a bad thing to hard code your values in. For example, you see here we are saying j less than 10. This is really bad design because every time you need to change the number of times that your loop is going to run, you're going to have to hunt for these loops and change these values. And this may be in a lot of places in your code. So a good thing to do is to put the value that controls how many times your loop is going to run in a variable like this. We're going to store that value in this count variable. Notice that it is of size t because it is a representation of the size of things, something we don't really want to be negative. And we're going to use this in our test part of our for loop here. Instead of saying j less than 10, we're going to say j less than count. And if we want to change this, we have one point of control to go and change this value here. And this is really good design. You should do this.
About watching anime at a friend's house.
We have talked a lot about
Hey man,
loops.
have fun with that.
It is time we headed over to Visual Studio Code and actually tried these things out. Here we are in Visual Studio Code. The current project is for loop here. We're going to grab the code from our template project and we're going to put that in place here. And we're going to open this in Visual Studio Code. So let's do that pretty fast. For loop, that's the current project. We select it and we open this in Visual Studio Code. We're going to open up our main CPP file, which is going to show up here. And we're going to remove things we don't need here. So let's remove that. Okay, the first thing I want you to do is the bad way to do things. Again, if we want to print I love C++ 10 times, we can do it like this. And if we run the program, it's going to work, but this is really bad design because you would have to copy and paste this, for example, 1,000 times or even 100,000 of times, and that's really bad. So if we bring up our terminal and build with GCC like we always do, the build is going to go through. You see, it's successful. We're going to clear and we're going to run Rooster and it's going to say I love C++ 10 times. If you count this, it's going to be 10 times because that's what we're doing here. But this is really bad design. You don't want to do something like this. So we're going to comment this out and do this better using a for loop. Let's say that this is the bad way, and we're going to use for loop, which is the good way, sorry. So we're going to start by declaring our iterator. So we're going to say for, we're going to say size t. Let's use unsigned int to show you that you can use that. And we're going to say I, and we're going to initialize this with a 0. And this is going to be the declaration of our iterator. This is the first part we have in this parenthesis here. We're going to put in a semicolon and put in the test. We want the loop to run 10 times. So it's going to run from 0 to 9. We're going to stop when I stops being less than 10. This is one way you can understand this. After we have our test in, we're going to put the incrementation part, which is going to change the iterator to make the loop move forward. And we're going to do that by incrementing our iterator. After that, we're going to put a pair of curly braces, not angle brackets, and we're going to fall inside the body of the loop. This block here, delimited by the curly braces, is the body of the loop, and inside here, we're going to put whatever we want the loop to run. So we can go down here and say, I love C++ 10 times, let's say that. But before we do that, let's say I, so that we know the current iteration where we are at. And we're going to put a colon and say, I love C++. This is going to be better to follow in the terminal, I guess. And we're going to put in our new line character, move to the new line. And we need to put our stream output operator here for this to make sense to the compiler. And this is our loop. Now if we run it, we're going to see exactly the same thing like this, but we're going to have these iterators prepended to the message so that it becomes easy to follow this. And again, how this is going to work, we are going to run our code to declare and initialize the iterator.
I didn't put a...
After that, we're going to do the test. We are going to start with I0. So 0 is less than 10. This is going to succeed. We are going to fall in the body here. And after that, we're going
looks a little weird.
Print stdc out, I love C++, and this is going to be 0. We're going to increment I, and we're going to do the test again. We're going to have to do is 1 less than 10. The test is going to be successful, so we're going to fall in here, and we're going to print a 1. And we're going to run the incrementation part again.
So this is where we run 0 to 9.
And we're going to keep doing this until we hit a point, for example, when we increment this to be a 9. And after that, we're going to run the test. We're going to say, is 9 less than 10? The test is going to be successful. So we're going to fall in here and we're going to print 9. And after that, we're going to increment again. We're going to run the incrementation part and we're going to make I a 10. If we run the test, we're going to say, is 10 less than 10? The test here is going to fail. We're going to stop running the loop altogether and we're going to fall on the outside of the loop and say, loop done. Let's say that so that we can see this on the terminal. And this is going to run and print I love C++ 10 times. And we expect I to go from 0 all the way to 9. Try to run this in your mind. Take a piece of paper. Try to print this as you fall into the body of the loop. You're going to see that's exactly what is happening here. So what we're going to do, we're going to build this again. So we're going to run the task to build with GCC. The build is good. We're going to go down and run this. We're going to clear and run rooster. And you're going to see that we have 0, I love C++, all the way to 9, I love C++. Our loop is working exactly the way we want. Okay, so this is the first step. We are able to run our code a lot of times without really having to manually do things like this. And the benefit of this is that if we want this to run, for example, 100 times, all we have to do is change our test to go until I is equal to 100. And we're going to stop when I stops being less than 100. And if we run this, we're going to see the message from 0 all the way to 99. And this is pretty cool. The total is going to be 100 times. So let's build again to show you how cool this is. We're going to run this task to build with GCC again. And we're going to clear, run rooster, prepare to be amazed, run, and it's going to run all the way to 99. We can change this to even 1,000 or even 10,000. Why not? We're going to build again. And
oh my god,
to be successful, and we're going to clear, and run rooster. And this is going to go
Holy
all the way to
shit.
10,000 times. We're going to wait for this.
Hold on. I'm running a million. I need to see this. I need to see this. Clear. Let's do it. Holy shit! That is so much! Oh my fucking god! You can see how fast it counts. That's so sick. He's drunk with power. Dude, I was like thinking about like, oh man, is a million like doable? Is that gonna like crash my program or something? Which like logically I was thinking about it, I'm like, nah, there's no way that it would do any harm, would it, right? And then I see him say like, oh, just do 10,000. You know, why not? And I'm like, why not? Why not indeed? Look at this shit. I printed I love C++ 100,000 times. Oh my god, dude, it's insane. We're halfway done, guys. We're halfway done. No big deal, dude. Just printing a million lines of code. You mean writing? No. What are you writing? Psh, that's insane. I'm printing it, dude. Oh my goodness, dude. This is insanity. Actual insanity. I printed a million lines of code. Oh my god, we're almost done, dude. We're 80% there. I love that you can actually see the numbers as like percentage marks. Essentially, 86%, 87%, 88%, 89%, 90. We're almost only oh man, only like 5% left, dude. We're so close. And a million! Yay! We did it! I've never seen a million lines of code before. I do think it's kind of funny that you can't scroll up past it. Like, I think it only shows... Let me see. It looks like it only shows the last 1,000 or so. Yeah, it only shows the last 1,000. But still, that's a fucking 1,000 lines of code. That is insane. That's awesome.
To get there.
They said
now,
he was a
3,000,
madman, that he couldn't do it.
5,000, 6,000, 7,000, 8,000, 9,000, 10,000. It's going to go all the way
I saw
to
it counting up and I was like, I need to see this with a million.
And it is going to stop. And the total of times the loop run was from 0 all the way to this stopping number here. Okay, now we can see that our loop is really working fine.
Yep, it works perfectly.
Do these stdc out statements a crazy amount of times. Okay, and the benefit again is that regardless of the number of times the code here is going to run, our loop is going to stay relatively the same. It's just going to be 1, 2, 3, 4 lines of code, and this is really cool. Okay, so I think this now makes it very clear how loops work. So we're going to comment this out and show you another thing. And we're going to show you that you can use size t to actually denote the type of your iterator. And it is easy to do that. So we're going to say use size t. And for us to be able to see all this here, let's hit this file icon here to close this pane. And we're going to have a better chance of seeing our code here. So what we want to do, we're going to declare a loop. We're going to say for. We're not going to say unsigned, and we're going to say size t. And this is going to be the type of our iterator. We're going to say I. We're going to initialize this with a 0. And we're going to put a semicolon, like we just did. We're going to put in the end test. We're going to put in the test. So we're going to say I less than 10. No problem with this. And we are going to increment to put in place our incrementation part. We're going to fall in the loop. We're going to say stdc out. This is the code we want to run. So we're going to put in our current value for the iterator. And we're going to say, I love C++ again. And
Yep.
we're going to put in our new line character. And if we build and run this, it's going to build and run the same. So let's say loop done here so that we know when it's done. And we're going to build and run. We're going to build with GCC. The build is going to be good. And what we're going to do, we're going to clear and run rooster. And this is going to say, I love C++ 10 times from 0 to 9.
What did I fuck up? Hold on. I fucked something. Oh, I'm an idiot. I plus plus or plus plus I. Oh no. What did I do wrong? What did I do wrong? Gotta figure my shit out. Let's clear this real quick. I still have the same issue. No. Okay, so I fixed it. Computer's like, tag me in, coach. Put me in, coach. I'm ready to play.
Again, the message here is that you can use size T to represent the type of your iterators. And this is a type that is even used in the C++ standard library. So this is going to be something
Type defined
people
as
expect
unsigned
from your
long
code if you are representing sizes in code that should be compliant with the C++ standard library. Nothing stops you from using unsigned int like we do here, but we're just going to follow the convention from the C++ standard library and use this type here to represent our sizes.
Okay.
And some of you might be wondering, how big is this thing? We have the tools to know how big it is, so let's do that pretty fast. So we're going to go down here and say stdc out, and we're going to say size of size T, and we can print this out. And let's say what we are doing here so that it is easy to use this code as the reference. And if we print this out, we're going to see the size of this thing on the system where this code here is going to run. So we're going to build with GCC again. The build is going to be good. We're going to go here and clear and run rooster. You're going to see that it is 8 bytes on my system. So you're going to have quite a huge range of numbers you can put in here because this is going to only be positive. Okay, if you try to put in a negative number, you're going to get an underflow, and we have learned about overflow and underflow in a previous chapter.
I don't think we have learned about overflow and underflow. I do know what those are, but I don't think that we've learned about them in this. I just remembered last night I looked up how long trombone is to tell you today, and in my dream I told you and you got pissed off. What? Why would I get pissed off about that? Like, is this a sign? Do you need to tell me, like, now because I have too many streams for it scheduled or something? Or, like, not enough? Or what's the deal? I don't think it's that much longer.
So let's comment this out and keep learning more things about for loops. Okay, the next thing I really want you to focus on and learn is the scope of the iterator. And we're going to grab our code again here, so that we can use this as a learning tool. So we're going to go down here and put that in.
I don't know why you were
And
pissed
what
off,
we're
because
going
I
to
thought the
have,
zombie
let's
animals were more
move
important
this
than
a
at the
little
time.
bit to the right. I think we
True.
can do something like this. I am going to select the entire thing here and hit tab, and it is going to be aligned with whatever we have here. Okay, so we have our loop. It is going to run 10 times. It's going to print I love C++ from 0 to 9.
Anyways, it
But
doesn't end after a million
what is
setting,
the
and at the
scope
end
of
you get
this
to play
I
as a server
think
bot.
here?
Ah.
And the fact is, it is scoped inside this loop here. You might have guessed that. If you try to use it outside the loop, you're going to get a compiler error because it is only usable inside the body of the loop. You can also use it inside
this makes sense.
the control part of the loop here, but you can't use it outside the loop. So if you try to print I here, for example, you're going to get a compiler error. So let's try and do that and show you how wrong this can be. So if we try to print I here, let's say I, to make it clear what we want to print. If we try to do this, we're going to get a compiler error because I is not in scope. It is only in scope inside these curly braces that show the body part of our loop. Okay, Visual Studio Code is showing the problem here. It's saying I is undefined here, so you shouldn't really do this. But if we move on and ignore the message from Visual Studio Code and compile, we're going to get a compiler error, and it's going to say, I don't know what you're doing here. I was not declared.
Wait, build finished with errors. That's interesting. Does that mean that it's... Okay, no. Build finished with errors does not mean that it actually did it. But yeah, we did see the problem. I was not declared in the scope. Identifier I is undefined. Okay.
Declared in this scope where you are using it. And I think it's even going to give me a line number. It's going to tell me 46. That's where you are doing something wrong. And if we go in our code, we're going to see that this is the line where we are making the mistake. So I is not in scope here. We're going to comment this out and say compiler error, I is not in scope. That's what you're going to get if you try to do this. And the main message is that if you declare your loop like this, I is only going to be scoped in the body of the loop, and that's the only place where you can mention its name and use it. If we comment this out and build again, the compiler error is going to go away. You're going to see that the build is good. Let's clear so that our output here is good. We're going to build again and show you that the build is good. And this is really cool. Build finished successfully. Okay, this is one way we can set up our loop, but there is a way we can make our iterator usable outside the body of the loop, and we're going to show you how you
he
can
talked
do
about
that
that, and that's just defining it outside of the loop, right?
Again.
Like that's
And
not
we're going to
terribly
grab the code
confusing.
because we
It's
don't
like any
want to
other
type all this
integer or any
again.
other
And we're going
variable,
to
whatever it
say
is you want to call.
iterator declared outside the loop. We're going to go down and put in our code, and we're going to align this nicely, and we're going to take the iterator and declare it on the outside of the loop. So we're going to say size t, and we're going to say I, and initialize this to 0. And we're going to say this very clearly, iterator defined outside. And we're going to say in our declaration part of the iterator, we're going to just say I. And this is going to work pretty fine. Ooh. If we build this, you're going to see that the build is good. And if we run this, it's going to do the same thing it's been doing. It's going to print I love C++ 10 times. And if you want I usable on the outside of the loop, now you can use it. We can grab the code here that was failing in the last run of our code and put that out here. And we're going to align this a little bit. And if we compile this, the build is going to be good. And if we try to run Rooster, we're going to see I love C++ 10 times. We're going to say loop done, and we're going to print the value of I. And you see that if we do things like this, I is going to be usable on the outside of the loop body. And sometimes these may come in handy depending on the logic of the application that you are designing. Just know that this is something you can do in your loops. Okay, you can go even crazier and leave out this iterator declaration part in your loop altogether. So you can remove that. And we're going to show you how you can do that in a minute. So let's comment this out. I don't want to remove code because I want you to have this as a reference if you need to look at this later.
What have I done to the terminal? Is that all terminal does? Does that really just like essentially just fucking push it down? I didn't realize that it was just doing that. Maybe I need to run another million lines. What the fuck is going on?
So we're going to say leave out, and what you can do is grab the code we had before. We're going to grab it and we're going to paste that in here. And what we're going to do is take out this I. This can work, and you may see code like this out there in the wild. So we're going to run this task to build with.
Whoa, okay, so they've removed the I here because I think they're running the test specific. So, oh, okay, that actually kind of makes sense. So this is I think this is what he called the start point before, but because the start point's out here, we don't actually need the stuff that's inside here to be, we don't need what's behind this semicolon. We just go, we just go ahead and we just do the test. And then if the test fails or passes, it does, it'll either end the loop or do this. So if we do this, all right, hold on. He made a whole second thing for it. So I'm going to go ahead and do like this. We're going to do a second copy. This one is going to have this removed. We're going to go like so. Do. Oh, we forgot to actually, you know what I can do? Do like this. I'm doing this the wrong way. My fucking face doesn't want to do that the right way. Yeah, and then we don't need this. Yeah, so we have our iterator defined on the outside. I want to take a note for this. This is I is still what is being tested. So, but because it is initialized before, we don't need to specify it at the start of the for loop. At the start of the loop. Let's say line 50. I'd like to think when he says, let's do it the incorrect way, his computer quakes with fear. We are going to do it the incorrect way. And we're going to get a compiler error. I think it's great. I think it's nice to show because, like, one of the things that I can imagine being a little bit worried of is like I mean, there's is making mistakes in the code and breaking your shit, but because we're running it in like Visual Studio, I think it's. I mean, I'm sure there's easy ways if you like. I don't know if you can like create like a .bat or whatever the fuck and delete system32 from VS Code. I mean, I'm sure there's a way to do that, but like you're not gonna like I don't think you're gonna accidentally brick your shit. Not without like an extremely severe like, hey, you basically asked for this to happen type thing. I kind of like that he has us do it the wrong way, and then we can like see in the terminal. I mean, this is all my own fault. Delete system 420. But like you see, imagine like this is your first time doing anything on a computer, right? And you just see this giant red like block of red text show up. You're like, "Oh my god, what happened?" And it's like it's just me clicking something wrong, basically. This is not even, this is like a little bit it's like a little bit concerning, but it's not like a huge like, oh, your computer is about to explode, because you decided to accept the mission or whatever.
With GCC, the build is going to be good, and we're going to clear and run Rooster, and it's going to do exactly the same thing. So this is one way you can set up your loops. Okay, the last thing we need to see about loops is that this test here is using a hard-coded value. And if we needed to change this loop to run, for example, for 1,000 times, we would need to manually hunt for this line of code, change this, and this is really not good design.
This is
what is recommended
another
is
thing that
to
he
store
mentioned
this value in a
in the
variable
lecture portion.
and test against that variable name instead. Let's comment this out and show you that. So we're going to comment this out and go down and copy this entire thing. I don't think I want to do my loops like this because this is really unintuitive most times. So I am going to declare my iterator inside, and I'm going to copy the code that does that here. We're going to go down and say, don't hard code values. Okay, we're going to say that it's really bad. And we're going to go down and show you a better way to do things. And again, right now we are hard coding in this value, but we can say const size t, and we can call this value count, for example, and we can initialize it with whatever we want. In this case, we want to control our loop to run 10 times. So we're going to put in a 10, and instead of hard coding in this 10, we're going to say count. Okay. And if we build and run it, the loop is going to do exactly the same thing. It's going to print I love C++ 10 times. So let's do that and run Rooster. It's going to do the same thing, but now we have one point of control. If we want to...
Okay, hold on. Let me make sure my stuff is working as well, because I think this makes sense to do, right? Because, like he said, here, what we'll do is we'll do... I think we wanted to do like so, and we want so we can show our how many things we are. I'm here for a minute. Have you had any questions? Not particularly. The biggest, actually, there's a kind of minor one, I guess. So in the for loops, the main the example, all the examples we've been using have been testing against a like greater than, less than thing. How crazy can you get with whatever you're testing against for your loops? Is it always going to be like some sort of... It always has to be a Boolean, I'd imagine, right? Like, oh, if this is true, run again. If this is true, run again. And then it like we iterate it here, but I guess it doesn't technically have to be iterated here. If there's like some other thing that controls the variable, maybe. I'm not 100% on how all that works. Anyways, I'm gonna print this so that I can see all of the what is it? Oh, whoops! I'm a silly Billy. I need to take this out and put it here. Yeah, and you can put true if you want, and it'll go on forever. I mean, I printed I printed a million lines earlier, so so but forever is like actually forever, isn't it? Like it'll just keep going until I like intervene. Alt F4 the program. Let me unfuck myself here. Get it properly and make it do what I actually wanted it to do. Which was not that. Oh, yeah, because I messed it up again. I keep messing it up. It's like a really simple thing. Ah, what the fuck was that? Alright, this time. There we go. That's what I wanted. I don't know why that was so difficult for me to do. Probably because I'm messing with text and it's just kind of weird formatting for me. Interesting. You should always define the iterator in the for loop. Yeah, he did talk about it a little bit. I thought it would be interesting to keep doing this, keep using the iterator on the outside. I think he did say that he hasn't said that the test thing should be defined outside, or like fuck, what he said is to not do not hard code values, right? So like when you test against this, you want this to be easily like all the other examples is just hard coded as 10, right? And we're just testing against the number 10. Whereas here we can modify this so that it's like, yeah, we can just change this to 100, and it's functionally the same thing. But yeah, so let's get this. Let's put this back in here, and then we can run. It should be, I think it was just size ti, like so. Like for int I equals 0 pointer. I count I plus plus. Yes, not having magic numbers is good. Yeah, yeah. Alright, so int I equals, yeah, I think here it's just automatically at 0. I hadn't defined it as 0, but it should be 0 with that, right? Yes, it's quite interesting. I do think I do feel like this chapter I've been doing a lot more just kind of listening and following along. There hasn't been a whole lot of like crazy questions that I have. Yep, that looks like it works. Yep, and that does exactly the same thing as it did before, but in a different way. It's amazing how many different ways there are to do the same things.
This to run for, let's say, 100 times, we can change the count value to 100 times, and if we build again, that's how many times the loop is going to run, and this is much cleaner. So I do recommend you store the values you use in your loops in variables like this.
Okay,
and it's
I'll
going
check
to
back in
make
an hour or two.
I
mean, I don't know exactly how long this is going to be.
It's going to run 100 times.
This one seems like it'll be shorter.
This is exactly what we want.
But we'll see.
This is really all we set out to do in this lecture. I hope
when you learn while.
Interesting.
Yeah, maybe. We'll see how long. We'll see if it fucks me up.
Turned out lengthy because we had a lot of things to talk about. But now I hope you really know a lot of things about ways you can use your for loops to make them do things. And again, many loops that we're going to use in our C++ code are going to have 5 parts. We're going to have an iterator, which is going to be a variable we use to manipulate how our loop moves forward and does things. The starting point is going to be where the loop is going to start. We're going to have a test in place, which is going to control when the loop ends. And we're going to have the endpoint encoded in that test. We're going to have the incrementation part of the loop, which is going to control how our loop moves forward. And we are going to set up a pair of curly braces that are going to contain the body of our loop. In this lecture, we're going to learn about while loops. And this is another construct we have in the C++ programming language to allow us to do repetitive tasks. The syntax for a while loop looks like this. We have 5 parts in our loop. We have the iterator, the starting point, the test, the incrementation, and the loop body. It's just going to be set up differently for while loops. The iterator is declared on the outside, and you see here we have unsigned int I, which is exactly the same type of iterator we've used in the last lecture, but note that you can also use size t here. I am just using unsigned int for this case. After you have your iterator declared, you're going to fall to this part here and say while open a set of parentheses, and inside you're going to put in your test. After that, you're going to open a pair of curly braces, and inside them you're going to put the body of your loop. And you're going to do whatever it is you want to do in the loop in there. And after your code to do whatever it is you want to do is executed, you're going to put in your incrementation part after your code. And that's what we have here. And this is the setup we're going to be using for our while.
Interesting.
Again,
so here in the while, we're incrementing after we've done, like, we're incrementing in the body. Which I'm kind of curious as to why you would do a for or a while, choosing one over the other. I'd be curious to see what the cases that you would do one or the other in. Because like it's not quite like edge cases, I don't think, but it is kind of like you would want to think about it carefully. I'd imagine. I'm sure. It seems like two different ways to do just the exact same thing.
We have
I don't know why you would do one over
iterator
the other.
declared on the outside, and we can initialize it with whatever it is we want to start with. Then we're going to put in our test. It's going to be within these parentheses. And after that, we're going to set up a pair of curly braces. And inside them, we're going to put whatever code we want to run in the loop. And then we're going to follow that with our incrementation part. And if we try to run this, we're going to run this line. We're going to declare the iterator I, and it's going to start with 0. So the test is going to run, and 0 is less than 10. And we're going to succeed, and we're going to run the body here.
It
we're going to
seems
say
like a
I love
while
C++,
has more
and after that we're going to run the incrementation part.
interconnectedness. Like a for loop seems like it's a lot more insular.
So 1 is less than 10. We're going to succeed. We're going to fall in. Print I love C++. We're going to increment again. Then we're going to have a 2 in I here. We're going to run the test again. We're going to say is 2 less than 10. That's going to be true. So we're going to be successful. We're going to fall in the body of the loop. We're going to increment and get a 3. We're going to test against our 3 value. 3 is less than 10. We're going to succeed. We're going to print I love C++. We're going to increment again. We're going to test again, and we're going to say is 4 less than
all
count,
the way up to 10.
or 10. We're going to be successful, and we're going to keep running until we increment and get a 9.
10 is not less than 10.
Once we get a 9, we're going to run the test again. And we're going to say is 9 less than 10. That's going to be successful. So we're going to fall inside, print I love C++. We're going to increment and get a 10. And if we run the test again, we're going to say is 10 less than 10. That's going to fail. And we are going to fall on the outside of the loop. And we're going to run whatever code is on the outside here. This is really how a while loop works. And I hope you can see the similarities between the for loop we have seen. It is really the same thing. We just have different syntaxes to do these things. Okay, if you look at these things, we really have the same pieces of information. It is just different syntaxes that C++ provides to do the same things. And sometimes you're going to find it convenient to use while loops, and sometimes you're going to find it convenient to use for loops. And you're going to have to decide what works better for whatever it is
show a case of choosing one over the other.
For now, we're going to head over
at least
to
like a
Visual
personal
Studio
one.
Code
Like,
and
oh,
try
I
this
thought
out.
this was
Okay, here we are in Visual Studio Code.
Like a doesn't oh yeah, you got to tie a personal story into your teaching. Well, like he says that doing one might be more convenient in a certain situation, but like I don't really understand why one would be more convenient than the other in any situation. Like the only thing that I can maybe think of is that a for loop would be something that is like maybe not completely isolated, but like you'd want to, it would be like a very small thing that you isolate from from the majority of the code, and then like a while loop would be more interconnected in a way and using those variables in places other than the loop. That's like that's kind of the vibe I'm getting from it. I don't know if I mean it seems like that's the case, given that a for loop, you can define the iterator inside of, and then the with the while loop, it seemed like you kind of had to define it outside. In both cases, you want to define the constant that you're testing against on the outside as well. So I don't know. I guess for loop is just more insular than while loop. That's kind of my guess.
Code, the current project is while loop. We're going to grab our template files and we're going to go in our project and put those in. And we're going to open this in Visual Studio Code. So let's do that. We're going to open the folder and we're going to work on while loop here. We are going to open our main CPP file pretty quick and we're going to get rid of this. And what we're going to do is remove what we don't need. And again, we're going to show you the bad way to do things. You don't really want to do this manually. We want
I'm
to
not
print
going
I
to
love C++
type that
10
out again.
times.
We already know that's bad.
We're going to build. Let's bring up a new terminal so that we can use this when we run things. And we are going to build with GCC. Let's do that pretty quick. The build is good. So we can clear and run Rooster. And we're going to have I love C++ printed out 10 times. So what we can do is comment this out and use a while loop like we want to do in this lecture here. And as we have seen with the slides, the first thing we need to do is declare our iterator on the outside. So we're going to say size ti, we're going to initialize this with 0, and that's going to be our iterator declaration. And we're going to say while I is less than the value where we want to stop. And again, we don't want to hard code these values in, so what we're going to say is really const size t, and we're going to call this count and make it uppercase. This is a convention we use to declare constants in C++, but you don't have to make them uppercase. It is just a convention that is going to make your code easier to read for other people. So we're going to put a 10 in here because we want our loop to run 10 times. And we're going to say while I is less than count, and we're going to set up a pair of curly braces, and they are going to delimitate the start and the end of the body of our loop here. And inside we're going to put in whatever code we want the loop to run multiple times. And the code is now very familiar. We're going to say stdc out, and we're going to print the current iteration, and we're going to say I love C++, stdendl for our new line character. And after that, we will need to put in our own incrementation part. If you forget that, you're going to get something really bad happen. We're really going to look at that later in the chapter, but for now, remember to put the incrementation part. And we're going to say ++i, this is really easy. And we're going to say that this is the test. And this is going to do what we want. But let's go down here and say that loop is done when it is done. So we're going to say loop done. And we're going to say stdendl. And before we run this, we're going to go through it and see how it is going to work. So let's click on this file icon here to close this pane so that we have some breathing room. I am going to open a notepad file we're going to use to see these things really happen. When this loop runs, we're going to initialize the iterator here. What we're going to do is put in 0, and we are going to run the test to see if 0 is less than 10, and the test is going to be successful. So we are going to fall in here and say 0, I love C++. So let's say that here to make this super clear. Inside the loop, we're going to print this message 0, I love C++. And after we execute this line, we're going to increment. I is going to become 1. We're going to go up again and run the test, and we're going to say is 1 less than count, or is 1 less than 10. The test is going to be successful. We're going to run
just
inside
demonstrating
the
now
loop,
the thing
and we're
we
going
saw
to
in the
print
last
1 I love C++. That's what we're going to do here. So let's
but the
do
I
that.
was now equal to 1.
And after we do
then
that,
it
we're
does
going
that
to
all
run
the way
our
up to 9
implementation
because
part
10
again.
is less than, or 10
I
is
is going to become 2.
not less than
we are
10.
going to run the test. We're going to say is 2 less
So it
than
goes
10.
0 through
That's going to
9.
be true, of course. And we're going to fall in
We've
the
already
body
seen
again
that.
and say 2 I love C++. So let's say that. We're going to increment and we're going to get a 3. We're going to run the test again. The test is going to be successful because 3 is less than 10. We are going to fall in here and say 3 I love C++. Okay, so we can really follow this.
Yeah.
And we are going to increment to get a 4. And the test is going to say, is 4 less than 10? That's going to be true, so we're going to succeed and fall in the body again. And we're going to say 4, I love C++.
Okay.
We're going to keep doing this, and we're going to increment again. We're going to get a 5. The test is going to run again. We're going to say, is 5 less than 10?
Okay.
That's going to be true, of
Mr.
course.
Garquia,
And we're going to
I
run
understood
the code
it
to print
2 or 3 numbers
I
ago.
love C++. We're going to increment again to get a 6. We're going to run the test. We're going to say, is 6
I have to do this
less
manga
than
stuff
10?
at 5
That's
a.m.
going
because
to
I
be
can't
true, of
concentrate
course,
through the rest of the
again.
day for
And we're
manga
going
for
to
some
print
reason, but I
6,
could
I
go.
love C++.
I could really go for some
And we're going to
unnecessary
increment
extra
to get
sleep.
a 7. We're
I
going
feel
to
that,
run
man.
the test, our iterator. We're going to say,
probably
is
gonna get
7
some-
less than
I'm
count?
probably gonna have like a chicken
That's
sandwich
going
or
to be
something for dinner.
true. We're going to print the message again and say 7, I love C++.
Is he going through
and
the
we're going
whole
to increment
code?
again to get an 8. We're going to say, is 8
I
less than
understand
count?
what the.
That's going to be true. We're going to fall in the body and say,
This would have made
8,
sense to do
I
on the
love
last
C++.
one, I think, because the last
We're
one
going
we
to
had.
increment to get a 9.
Last
We're
one was
going
the
to
first
run the test
for
against
loop
our
that we had
9.
seen.
Of course, 9
This
is
is
less than 10,
kind of
so
the same
that's going
concept,
to be true.
but-
We're going to fall inside, and we're going to say 9, I love C++. And after that, we're going to increment again, and we're going to get a 10. Now, if we run the test, we're going to say, is 10 less than 10? And that's going to be false, because 10 is not less than 10. And if the test here fails,
What you should
we're
have
not going
done,
to
I
fall
think,
in the
is
body
probably
of the
done it.
loop. Control is
made
going
count
to
like
fall
4 or
at
something.
the end of the loop body, and we're going to print loop done. That's what we're going to say here. We're going to say loop done, and our loop will have run 10 times by the time we print this loop done message here. If you count here, you see that the loop is going to run 10 times, and it is going to say, I love C++ 10 times, which is really what we want. Okay, I really had to show
Have you seen the
this
official
manually
Power
so that
animations
you
within
can
Kill a Pal
really
and
see
show
what
you
is
how to cook
happening.
it and eat,
But now we
cut
can
and
go
cook it?
and run this, and
I have
let
not.
the
I've seen the
computer do the
Pokemon
heavy
ones that are
duty
unofficial.
of running this and showing us all these messages. So the build is going to be successful, of course. We're going to run Rooster, and it's going to exactly show the same thing we just came up
I had
in our
this up here.
trusty notepad file here. You see, it is the same thing. But the beauty is that we don't have to do all these crazy computations again. What we can do is we can even change the count to 100, so it is going to run for 100 times.
So this is the same thing
That's
as
pretty
before.
cool. So we can clear and run Rooster, and it's going to do that 100 times, and that's pretty fast for computers. This is really all we had to share with you in this lecture. The main thing is to learn about the syntax of a while loop. And again, notice that we have these 5 parts that make up our loop. We have an iterator, we have the starting point, we have a test, we have the incrementation part, and we have the loop body. It is just set up differently with a while loop, like we can see here. In this lecture, we're going to learn about do-while loops. And this is yet another construct we have in C++ to do repetitive tasks. Let's look at the syntax here. We have our declaration of...
So we're defining our thing on, or what is it? Our test variable on the outside. We're defining our iterator on the outside, and then we have a new vocabulary in do. So do print. So we're printing this. It's the same concept as what this is doing, but it's so much more complicated for some reason. I mean, look at this. What is the point? Why are we putting it in brackets? And then also having this here. I love C++. That seems like a lot. And then this is our increment, and then this is the test. So this seems a little bit... So this is while I is less than count. And it looks like it's incrementing before, and then we have the while here. So we do this, we print, so right here we have I is 11. So it should print 11, I love C++. And then we're incrementing I to 12. So then while I is less than count, it'll be Oh, okay. So it looks like what it does here that it's doing differently from this is that it runs the test after the code has been executed, and I think after that, so it says do this while this is true. Interesting. I watched one for the sheep pal and my soul has weakened, but I would also eat the pal. I mean, the pals are pretty delicious. I played a pretty like what's my hours on Pal World? I think I have like a little under 100, like 80 some, 90 some. Oh, great, fantastic. I love it when I'm not connected to Steam for some fucking reason. Yeah, 96.6 hours on Pal World. This is interesting. While loops are kind of lame, but do while seems kind of... There's something here.
The iterator on the outside, and after that you're going to say do. You're going to put a pair of curly braces like this. You're going to put whatever code it is you want to run inside the loop, and then you're going to do your incrementation. And after the closing curly brace, you're going to say while, and you're going to put in your test. This is really the structure. Again, notice that we have those 5 parts in. This is the declaration of our iterator, and we're going to initialize this in place, for example, if we want to do that. After that, we're going to fall in the body of the loop. And after that, we're going to do the incrementation after we run the code it is we want to run in the body of the loop. And then we're going to do the test later. And the special thing about a do while loop is that it is going to run first and then do the test last. And this is really something you need to be careful about. Make sure that when it runs, it is doing whatever it is you want to do, because the test is going to run after your code has actually run. And you can tweak this to do whatever it is we want it to do, as we are going to see when we hit Visual Studio Code in a minute. Okay, again, one thing you need to keep in mind is that the do while loop is going to run the body of the loop and then do the check or the test, and that may come in handy in some of the applications you'll be doing within your career as a C++ developer. Okay, this is really the syntax we're going to be using. We're going to head over to Visual Studio Code and play with us. Okay, here we are
to me, it seems like what that means is that it would do the thing one more time than the for or while loops.
Template files pretty fast, and we are going to put them in our current project. Let's open this up and put them in there. And we are going to open this in Visual Studio Code. Do while loop is our project. We're going to open this, and main CPP is opened up. So let's remove whatever it is we don't need. And we are going to show you the bad way to do things. The bad way to do things is typing your code to do things manually if you want them to be done multiple times. And this is something bad. If we build this and run, we're going to go down and run this. Clear, not that gibberish. We're going to run Rooster, and we're going to get I love C++ 10 times, and you don't want to do something like this. What we want in this lecture is to use do while loops to solve this problem. We're going to comment this out because it is really bad.
Yeah,
and we're going to go down and set up our do while loop. The first thing we need to do is to set up the count, because we want to store this in some variable. So we're going to say constant count, and we're going to put in our value. Let's put in a 10, not 190. We're going to say 10 times, and we're going to set up our iterator. We're going to say size t, and we're going to say I, and initialize this with our starting point. We're going to start from 0, and what we're going to do is say do and put a pair of curly braces, and inside this pair of curly braces we're going to put whatever it is we want to do multiple times. So we want to print I love C++, so that's what we're going to say. We're going to put in the current iteration, and we're going to put a colon and say I love C++. And then we're going to jump to the new line, with stdendl. And after that, we don't want to forget our incrementation part. So we're going to say plus plus I. And this is going to be the part that moves our iterator to the next step. This is going to be the incrementation, and this is going to be the iterator declaration. And after the closing brace, we need to say our test. So we're going to say while, and we're going to put in our test here, and we want to keep doing this as long as I is less than count, of course. And we're going to put in our closing semicolon here. Now, this code is going to run 10 times. But let's go through how it's going to run so that you can really see everything.
Oh no, is he going to go through all of them again?
Okay, so when this code here is run, we're going to hit the initialization line here. We're going to declare I, and we're going to put in a 0. We're going to say do, and inside we're going to print whatever we have in I and say I love C++. So we're going to say 0 because I is 0 at this point, and we're going to say I love C++.
Yeah.
And after that, we're going to increment. I is going to become 1. And we are going to do the test at this time. We're going to say is 1 less than 10. That's going to be successful. So we're going to run the body again.
Please tell me you truncated
and
this
we're going
time.
to say 1.
This is very helpful if this is the
Let's
first time
copy
you're
this
seeing
and print
this concept.
again so that we don't have to type this all the time. We're going to say
you
1.
probably don't need
I
it
love
broken
C++.
down in
And after that, we're going
like
to run the incrementation part again. So we're going to get a 2
I do think
inside
it's
I
do think it's interesting that
say is
it
2 less
increments
than 10.
after,
That's going to be true. So we're going to run the body again.
We
and
run the
print
test after.
2 I love C++.
That definitely is like
and we're
an
going to
important
increment
distinction,
to get a 3 in there.
but I don't
We're going
quite
to run
understand
the test
how it's going
against
to
our
affect
3
anything that we
is
do
3
yet.
less than
like,
10. That's
I
going
know
to
it
be
does
true, so
have
we're going
an
to
effect,
volley the
otherwise
body
they wouldn't
again
cover it,
and
otherwise these
print
things wouldn't
3
exist.
I love C++.
There's a reason that
Let's
that
do that.
that
We're going
it's
to
used.
do the incrementation. We're going to get a 4
I'm just
inside this I
as to
variable here. We're going to run the test. We're going to say is 4 less than 10. That's going to be true, of course. We're going to say 4 I love C++ when we fall in the body again.
Oh my
We're going to do the incrementation and get a 5. Fall in, say that
I'm skipping ahead. I'm sorry. We saw this like not too long ago.
Loop here. So if we had a statement here that said stdc out loop done, we would print that. We would go down here and say loop done. And this is what we're going to get if we run this program. And again, I encourage you to try this out in your mind. Print this in some file you have on your computer, or you can even use a regular piece of paper, but make sure you understand the flow we go through to get this code to run multiple times. Okay, now that we have done this, we can build this and let the computer do the heavy work for us and run these things multiple times. The build is going to be good. So what we're going to do, we're going to say clear and run rooster, and it's going to say exactly what we expect. I love C++ 10 times, and then it's going to say loop done. Okay, one thing I want you to see is that the do while loop runs before it does the test. And this may cause crazy things happening in your program if you're really not careful. Let's say that you wanted this program not to run and initialize this thing with a 0 for the count. So it's going to run 0 times. But that's not going to do what you expect with the do while loop, because it runs things before it does the test.
Yeah.
So if you run this program, it's not going to just say loop done. It's going to say I love C++ and have 0 value in here, and it's going to say loop done. But that's not going to be probably what you intended by putting a 0 in here. You put a 0 in here if you want this code to run 0 times, or the code in the body not to run. That's another way to say that. But in this case, a do while loop is not going to do what you expect, because it runs before it does the test here. Let's build this and show you this. So we're going to go through. The build is successful. And we are going to clear and run rooster. You're going to see that it's saying 0 I love C++ loop done.
With the way that
it is running, even if we set our count to 0 here. So be sure the do while loop is doing what you want. But if you are careful about this, you're going to have no problems. And if you want the loop to actually not do anything, when you have 0 count in here, you can use the while loop or the for loop like we have seen before. I would like to welcome you in
Oh,
this new
hold,
chapter.
that was a sudden transition to the next chapter. Okay, so let's go over what we've learned. This was array, yeah. This one's gonna be a little bit shorter, I think. But I'm kind of happy to end it where we are. So let's real quick. I'm gonna go ahead and close this, and we're gonna make that the whole thing. So the big thing that we covered, obviously, is loops and the way that they work. So let me open up the other folder as well, so that we can. Is there no way to have both of them? Okay, whatever. This is the one that has most of the stuff, anyways. So the big thing, right, is this. If you want to do this, this is like a obviously we're using printing stuff to the terminal because this is the very beginning. I still feel like we're at the very beginning of learning the basics of C++, but this is a stand-in for any repetitive task, right? This is anything that we want to do like 10, 20, 100, 1,000 times, 1,000,000 times even. And so obviously just doing it again and again and again is not good. It's like creating functions, right? Like we create functions so that we don't have to keep typing out the same code a billion times in a bunch of different places. Especially in cases like this where you want to do it again and again and again until some condition has been met. This being our condition that is being met. So basically, anytime that we're going over this stuff, so a for loop, this is what I'm kind of unsure of still, and I'll probably message Lazy after this if he doesn't like come back. But the biggest thing that I took away from this is that the for loop, we define our iterator inside the for loop, and then we have our thing here, which we probably still want to keep on the outside. And it seems to me like the for loop is very insular. You want the for loop to be like a tiny little section that is by its lonesome. As kind of my understanding of why you would do a for versus a while loop. And then a do while loop is very similar, except it runs the test. This test portion after the body of the code, unlike the for loop and unlike all of the ones that are on this one. It runs the thing afterwards, and I'm not 100% certain on why you would want to run the test before or after, like what the benefit of doing one or the other is. I'm sure I'm sure there's reasons to do both, but to me, as of right now, it seems like functionally running the test afterwards, at least in these cases, is going to just make it run an additional time, so to speak. Like if we let me open my folder again. I'll open this one. So like if we have our count, we want our count at 10, right? Clear this. We have our count at 10, we initialize at 0. It seems like this should print it 11 times because we're using the same like if is my understanding. So let me test this real quick. Terminal, run task. No, it doesn't. Why? What am I misunderstanding? So our count is 10. Initialize at 0, so it prints 0 and then does the test. It doesn't go an additional time. It runs the test at the end. Yeah, no, it's just... Yeah, okay, so because it runs the test, it still runs the test where at the point where I equals 10, that part still goes before, like, this where I equals 10 is still less than it still ends up being before this. Okay, so that was okay. That's not as intuitive as I initially thought it was. It seemed to me like it would just go an extra time compared to a while loop. I mean, it works just fine. I don't know why you would want to do one of these over like a while loop or a for loop, though. That's kind of what I'm not sure about. It's like there's multiple. It seems like it was what 3-4 different ways of doing the exact same thing, and I'm not 100% on why you would choose to do one or the other. But I know how to do them all now, and I understand how they work and in the way that they're written. I mean, fundamentally, what it is a piece of code that is sectioned off to loop for one purpose or another. And it runs multiple times. I think it's interesting. It's an interesting. It's interesting that this exists. I'm curious what we're going to use it for, how it's going to be applied, I think is the best term. I one of the things that I would criticize with this is it seems pretty clear. It seems pretty clear to me in the video, um, especially when we were doing when on the do while and while loops. I think that my biggest criticism of this section so far would be it's pretty clear that they started as multiple videos and were just pasted together, which it's not that it's been totally seamless the rest of the time, but it did kind of become a lot more obvious, especially when he opens up Notepad again and he's like, "Oh yeah, we're gonna go through and we're gonna like we write the whole thing and it'll say, oh, 0, I love C++," and just doing that, I I can appreciate doing it the one time, doing it even I can appreciate doing it the first time. I think that it could have been cut out. I think if you were going to do it, you should have done it in the first section that we learned when we first got into for loops. I think that would have been the place to do it, and then I think you could have probably cut that part out of the subsequent chapters. But I mean, it's overall a pretty minor thing. I think it's still a very informative video, and it is helpful to reiterate something like that because it does. I mean, it is exactly that. It makes sense that it's like, okay, so we come here. I love C++. Increment I, and then we check, and then we test I again, and then if this still holds true, then it's like this, and then this. No, we run the block of code again, and then we iterate, and then we test, run the block of code again, iterate, test fails, we come out to the loop done. My dumb JoJo reference in chapter 2. I'm looking forward to reading it. All right, but anyways, let's go ahead and close this, and I hope you guys had a good time hanging out with me this afternoon, doing something little bit less. It was a little bit shorter. It was a lot of. It was something that I kind of had a grasp on. I think my biggest thing is going to be wondering when I'm going to use one over the other and uh, what would be better to use. And identifying situations where one is more advantageous than another. But yeah, shit, dude, I'm like fucking rambling now. Anyways, I hope you guys had a good time again. We're gonna be streaming. I think it was Tron Bond tonight. Let me see. Let me look at it because I'm kind of a silly Billy. And I don't know my own schedule. Yeah, okay. So we're doing some more Tron Bond tonight. That'll be in 6.5 hours or so. 11 p.m. Eastern. I hope you guys. I hope to see you there, and we will be back in however that many hours, however long it is, in until 11 p.m. U.S. Eastern. So see you then. Later. Bye.